Alright everybody, this week we are talking about the integumentary system and the endocrine system. So we're going to get started with chapter 4 and talk about hair, skin, and nails. So we've got a handful of learning objectives here. I'm not going to read through each of them, but we are going to look at the structure of skin, all of the accessory structures like hair, skin, nails, and sweat and oil glands, and kind of look at how this impacts homeostasis in the body and some of the common diseases of this system. So this video is going to cover section 2, which is layers of the skin. So let's get into it. So our skin is made up of multiple layers of cells and tissues that are anchored to those underlying connective tissue structures that we've talked about in previous weeks. The two main layers include the epidermis and the dermis. The epidermis is going to be the upper layer. That's made out of very, very tightly packed epithelial cells, and then the dermis is the layer that's actually going to have a bunch of blood vessels in it, as well as the anchor points for all of the accessory structures like hair follicles and sweat glands. So this is what our skin looks like, just kind of at a glance. So we can see right here, this upper layer is the epidermis, so very, very thin layer, just that outer layer of skin. There are no blood vessels going through here, which is why when you kind of lightly scrape your hand or your arm on something, and sometimes you can see where some of that layer of skin came off, but there's absolutely no bleeding whatsoever, and it's because there's no blood vessels in that layer. And then underneath that is the dermis, which is the majority of what makes up our skin is this layer, and you can see we've got some special muscles in here. These are called the erector pili muscles. They are connected to hair follicles, so this is what makes your hair stand on its end and kind of rise up. And then we've got those hair follicles, lots of blood vessels, some different types of nerve cells in here, oil glands, sweat glands, all that kind of stuff. And then beneath that is something called the hypodermis, which is mostly going to be a lot of subcutaneous fat, which will help a little bit with insulation and with cushioning for our skin and the structures underneath it. So the epidermis is made out of keratinized, stratified squamous epithelial tissue. So that means that these are stratified squamous cells. If you remember back when we did our cells and tissues in weeks 2 and 3, these are going to be specifically structured and layered cells. We'll see an example of those in just a little bit. And then the keratinization. Keratin is a protein. This is what our hair and nails are made of. And so that outer layer of our skin has that keratin protein in it to give a little bit of durability to that epidermis layer. Again, this layer is avascular, which means there are no blood vessels in it, and this is usually going to be 4 to 5 layers of these stratified squamous epithelial cells, depending on where it's found on the body. And so if it has 4 layers of cells, it's considered to be thin skin, and then if it has 5 layers, it is considered to be thick skin, which is really only found on the palms of our hands and soles of our feet, which makes sense because those have a lot more happening to them, so they do need that extra layer that's very, very beneficial to them. So here we can see an example of that thin skin versus thick skin. So over here in panel A is thin skin, so you can see how thin that epidermis layer is right here. And then in panel B we have thick skin, and again we've got this surface layer of those epidermis cells. And so you can kind of see how different those layers look. So we have a bunch of different layers of the epidermis. From the deepest layer, so the one closest to the dermis, is the stratum basale, and then stratum spinosum, stratum granulosum, stratum lucidum, which is only found in thick skin, and then the top layer is the stratum corneum. So all of these layers except the most deep one are going to be composed of keratinocytes, which are going to produce that keratin, and then they will actually die after a certain point in time. So this is kind of what that looks like. So we've got that outer layer, the stratum corneum. This is dead cells that are full of keratin. All of the cells underneath that are going to be living, but they do progressively get closer and closer to dying as they get closer to that surface. All right, so starting down here in that base layer, right where it's connecting into the dermis, that stratum basale, this is that deepest layer. These are going to be bound to that dermis with collagen fibers. This is referred to sometimes as the basement membrane. There are some finger-like projections called papilla coming up from the dermis. We'll talk a little bit about those later. And that can really help increase the strength of connection because it increases surface area. So this is going to be a single layer of cells primarily made of a cell type called basal cells. These are more cube-shaped cells, as you can see. This is the precursor of keratinocytes, and so they will develop into those keratinocytes in the next layer as we are continually dividing and making more copies of these cells, and the upper layers are flaking off slowly. So these are constantly going to be going through mitosis to produce those new cells, and that pushes existing cells, so the more superficial ones in these upper layers, out and away, which is what is helping our skin, that surface layer, to flake off. You're always losing skin cells constantly, all the time, all day long, 24/7. This is a constant process that's happening. So that's going to push those out. And then there's a couple other cell types that can be found in this layer. One of them is called a Merkel cell that we see pictured right here. These are also sometimes called tactile cells. So these are the nervous cells that are sensing things that touch. So that can be pressure or light touch and stuff like that. So that is where we're getting that sensation from. And then the other type of cell that we can find in this layer, pictured over here, is melanocytes. These are the cells that produce the pigment melanin and give hair and skin its color. So this is what's going to increase in number and production of melanin during the summer if you're getting a lot of sun exposure. Some people are going to have more pigment produced than others. I do not have a lot of these, especially anymore, but that's okay. There's nothing wrong one way or the other, but that is the cell type where we're getting that pigmentation from. So here's a histology image, so a slice from skin showing these different layers, just to kind of give you a little bit more of a comparison. So that lower layer, stratum basale, stratum spinosum, as you can see, is quite a thick layer, stratum granulosum, stratum lucidum, and then stratum corneum is this upper layer again. So we talked about this layer already. We talked about those basal cells, Merkel cells, and melanocytes. So again, we're binding that layer to the underlying dermis with collagen fibers referred to as the basement membrane, and we have those dermal papillae that are going to increase the strength of that connection. The stratum spinosum, that next lower layer, this is going to be usually 8 to 10 layers of keratinocytes connected to each other via something called a desmosome. This is one of our cell junctions that we talked about back earlier on in the semester in week 3, I believe. These desmosomes, they're going to interlock with each other to strengthen that attachment bond between the cells. And so these are going to keep everything tight, close together, and keep it all anchored in there. So lots of layers here that we saw in that histology image a couple slides ago, that stratum spinosum. You can see there's lots and lots and lots of cells here. So We really need to keep those cells connected to each other. So these keratinocytes are going to start creating that keratin. So we've moved up from our basal cells. Now we're starting to create that keratin. And they're also going to produce a glycolipid that's going to help repel water, which is going to help prevent water loss from the body, since obviously we want to keep as much water in our body as possible and let our urinary system excrete whatever's necessary, because that's what it's really, really good at. And this also helps our skin be slightly waterproof. So it's not perfectly waterproof, obviously, but our skin is pretty waterproof. Mixed in here with these keratinocytes are Langerhans cells. These are a special type of something called a dendritic cell, which is part of the immune system. So in this layer, we do have some of these immune cells that are going to help take care of bacteria and any foreign particles or damaged cells that end up being found in that layer, since we can get a lot of bacteria and dirt and stuff like that down into this layer without even getting that blood vessel damage that we would get with a deeper cut. Next up is the stratum granulosum. This is going to have a much more grainy appearance because the keratinocytes are really starting to produce a lot of keratin particles. And so if we go back, we can see right here in this image, we're starting to get all of these little dots in here from that keratin production. So we're really starting to fill up these cells with keratin. This is only going to be about 3 to 5 layers of these cells that are forming the stratum granulosum layer, and we're going to make lots and lots and lots of keratin, as well as something called keratinohyalin. Alright, so that hyalin should seem somewhat familiar. We talked about this with cartilage and stuff like that already. So these granules are going to be a slightly different type of protein other than keratin. Alright, and so these are also going to incorporate some of the intermediate filaments from the cytoskeleton. So this is going to have a little bit more structure to it and support. And so these proteins are made pretty late in keratin synthesis, and this is what gives these cells most of their structure and stuff like that. At this stage is when we start seeing a lot of the organelles and the nucleus start to disintegrate and disappear as these cells are starting to die now that they're really packed full of keratin. But we still have one more layer to go before our outer layer. Now we're going to talk about the stratum lucidum. Again, this is only found in thick skin, so the palms of the hands and soles of the feet, because we do need a little bit more durability to our skin in those particular areas. This layer, where it's found, is going to look very, very smooth under a microscope and can kind of seem translucent or see-through. This is going to be just below that outer surface of cells. And these keratinocytes that are making this up are going to be dead and flattened because, again, keratin's a pretty durable protein, offering a little bit more protection in those areas where we are doing a lot of mechanical damage to our layers of skin. So these keratinocytes in this layer are densely packed with something called elodin. This is a clear protein that's also rich in lipids. So it's a protein and lipid linked together. And this is derived from that keratinohyalin that we talked about in the stratum granulosum layer. And that is what's going to give these cells that transparent appearance and also helps provide more of a barrier to water. Last but not least is our stratum corneum. This is going to be anywhere between 15 and 30 layers of keratinocytes. We have a lot of keratinization here because this is that final stage of these cells. Keratinization is sometimes also called cornification, so just a slightly different term for it. This is the layer of our skin that is exposed to the external environment, and this is the layer of our skin that we are shedding constantly every second of every single day. So these get shed regularly. An entire layer gets replaced roughly about every 4 weeks, so this is a constant steady replacement over the course of about 4 weeks, and then it starts over again. But you are losing skin cells continuously, which is why a lot of people like to exfoliate and stuff like that. And so that is also allowing us to damage this layer a little bit and lose those dead keratinized cells without damaging the underlying layers of cells or the deeper tissues. Then we'll talk about the dermis. So this is deeper. This is going to have our blood and lymphatic vessels, nerves, hair follicles, sweat glands, oil glands, and we have 2 main layers of connective tissue here, the papillary layer and the reticular layer. So the papillary layer is this more superficial layer. This is what is connecting to that basement membrane of the epidermis. And so this is what's forming those dermal papillae that are increasing the surface area, so we have a really nice strong connection with the epidermis above. And then the reticular layer is deeper down underneath that and has a lot more of those other structures, as well as some extra elastic and collagen fibers. So the papillary layer, this is going to be loose areolar connective tissue with those dermal papillae. We are going to find some lymphatic capillaries, nerve fibers, and something called Meissner's corpuscles located in this particular layer, but not a whole lot going on in that papillary layer because it is smaller. But the fibers in this layer are forming a very loose mesh-like structure, and so that's just kind of helping to increase the flexibility of our skin, is not having those packed in too tightly. So there are going to also be those lymphatic capillaries. So we're not really seeing blood vessels in this layer, but we do see lymphatic capillaries. We'll talk more about those when we do the lymphatic system later in the semester. We do have some nerves in there and Meissner's corpuscles. These are part of the nervous system, and these are specifically touch receptors. They can also sometimes be called tactile corpuscles. So this is a nerve structure that is responsible for sensing light touch specifically. So not pressure or pain or anything like that, but light touch. And then the reticular layer is dense irregular connective tissue, a lot more densely packed collagen and elastic fibers in here. Again, those elastic fibers are enabling a lot of movement and elasticity, so allowing us to have that skin stretch quite a bit. And then those collagen fibers are structure and strength. They're going to extend up into the papillary layer and then into that hypodermis layer below it. Collagen also links into water and helps keep the skin hydrated. Collagen injections have become pretty popular in recent years. And then retinol creams, or retin-A creams like tretinoin, also help in kind of introducing that collagen to be produced a little bit more, and helping blood flow increase to repair that dermis. And then the hypodermis is the subcutaneous layer, or superficial fascia. This is, again, deep to the dermis, lots of vascularization here, and then loose areolar connective tissue and adipose tissue. So this is fat storage, which gives some insulation and some cushioning again. And then those melanocytes, again, are producing that melanin. So the sun exposure is going to stimulate some of these keratinocytes to secrete chemicals that are going to stimulate those melanocytes. So the melanocytes themselves are not being stimulated by the sun. It's a little bit more of a domino effect that's happening there to get those to produce a lot of that melanin and make skin and hair darker, or decrease that production of melanin and make those lighter in color. So here we can see lots of this melanin pigment here represented by those little dots. That is going to give skin and hair a darker color. And then if we have less of that melanin, then we are going to have much, much lighter skin or hair. And that melanin, as you can see, is getting distributed from the melanocyte out into the keratinocytes. And we'll continue in our next video talking about some accessory structures of the skin.